Hi guys, I'm now going to go ahead and go over science with you for week 22. This week we'll be making a popsicle stick catapult. For materials, if you picked up your materials from Katie, you will use 7 to 20 popsicle sticks, 4 to 20 rubber bands, craft glue, and for launching materials, we have a couple different things. There's these little pom-pom balls that were in there. You can also use mini marshmallows, popcorn, ping pong balls, all kinds of different things. I have attached a resource to be able to line up maybe some Lego men to launch some things at, see if you can knock them over, see how far your pom-poms can go. The boys and I made these. They actually colored them to make them look like catapults, and then the other one. One has more rubber bands. This one has the rubber bands across the spoon, if you can see them there. This one does not. Jackson made one too. However, his did not last. He made one that looked like this middle one here. If you guys can see that. And he shot it and it broke. So I will show you these pictures here in a minute so you guys can maybe look at those a little closer. It is on our CC Connected page under Nicole Liam. So if you guys have all signed up for CC Connected, you can find that resource there. So just go over with your students on how to make them and what the activity is going to be. Each student can make its own unique catapult. And think about what you've already learned, the difference between kinetic and potential energy. What are Newton's 3 laws of motion? And then what do you notice about each catapult? How are they different? What differences might affect the launching distances? Okay, there are many different kinds of catapults that have been used over history, including the famous trebuchet and ballista of the Middle Ages. No matter which design you came up with to launch your projectiles, each catapult needs force and energy to get flying. That's the science of physics or movement. As you pulled back on your catapult, making it ready to launch, potential energy was stored up. The tension created in the rubber bands builds up the potential energy and the force needed. When you let go, you released that potential energy and it transferred it into kinetic energy. Remember those? Or potential energy can build up. Other factors could be the mass, or the weight of your projectile, and of course the aerodynamics of your object. Once in air, its forces and gravity and air resistance that slow down your projectile, causing it to arc and eventually land. Before the inventions of cannons with explosives, catapults were the most effective launching machines. So which catapult design were you guys do? So then here's some different ones. Here's a picture of an actual catapult. See that there and all the parts. And here's 2 different catapults up there. And there is 3 more down at the bottom there. So which one will you guys do? Make sure you send them to us or post them on our private page so we can see which catapults everybody does this week. They certainly were a lot of fun. So just put your little guy right in there and, oh, I can't get it to stay on. So fling it. Just like that. So fun. I'm sure the boys will be flinging these at everybody, but we are going to do the little Lego thing that I sent for you guys. This one flings it really, really far.
Mommy?
Like that. Okay? So I can't wait to see everybody's catapults. And then I've also attached an additional resource of a dad doing the experiment at home. And he will walk you through the experiment in a little bit more in detail. And then also there's a resource about catapults. So a catapult is a type of machine used as a weapon to throw rocks or other things such as hot tar. Ugh. That would cause damage or to something else. Often catapults were set on higher ground or on castle towers to let them shoot farther. They shot rocks to break castle walls, to pitch hot tar, or set it on fire. So then here's some other pictures of catapults. You guys see those there? Okay. Catapults use weights and levers to send the rocks to other things in the air. They do not throw as far as modern weapons do and are not useful in modern warfare. warfare. Sorry, guys. Catapults were common in the past, especially in the Middle Ages. Nowadays, catapults are used to study old weapons and as experiments, for example, in physics or in engineering class. And some old ones are kept in the museums. This one here. See that one there? Pretty cool, huh? Catapults, or castles and fortified walled cities, were common during this period, and catapults were used as a key siege weapon against them, as well as attempting to breach the walls. Missiles could be thrown inside, or early biological warfare attempted with deceased carcasses or putrid garbage, catapulted over the walls. Defensive techniques in the Middle Ages progressed to a point that rendered catapults ineffective for the most part. The Viking siege of Paris saw the employment by both sides of virtually every instrument and siegecraft known to the classical world, including a variety of catapults, to little effect, resulting in failure. The most widely used catapults of the Middle Ages were as follows. And those were the ones that I sent you, or I showed you there. Those two, okay? There's just a little information about catapults. I hope you guys have a lot of fun with this one. We certainly did. Cullen, which one was yours, buddy? This one. All right, so this is the one Cullen made. You want to tell them about it?
So I used coloring pencils to color the blue and red.
And then how many popsicle sticks do you have put together down here at the bottom?
I have 1, 2, 3, 4, 5.
5 for the bottom part. And then you have 1 here behind your spoon.
Yep.
And then 1 for the base.
Yep.
And then what did you use around here?
I used rubber bands.
To keep it together. Do you want to fling it? Do you want to use it? Okay, where'd the little puff ball go? All right, you want to fling one? All right, let's see how far you can fling it. Make sure they can see. Whoa, that went pretty far. Good job, buddy. All right, say bye.
Bye.